Before we start, let's answer one question. What exactly is MCP Server? MCP Server stands for Model Context Protocol or Micro Agent Communication Protocol. It is a new open standard that lets AI talk to our external system in a safe and structured way. Think of MCP like a toolbox we plug in into the AI. AI itself can't access our files, our databases, our APIs unless we expose them as a tool through the MCP server. So MCP server does three things. First, define tools. These are actions the AI is allowed to perform, like running SQL, listing table, reading files, sending messages, querying APIs, etc. Second, controls access. AI can only use the tools we expose it to. Nothing more, nothing less. This makes it safe, modular, and predictable. And third, act as a bridge. It sits between AI model and our real system, translating AI request into the real operation. In simple terms, MCP server gives our AI superpowers, but only the one we choose to. And today, we are going to build one from scratch. We will connect it to SQLite database, expose SQL tools, and teach an AI agent to understand natural language and turn it into SQL. Basically, we are building a brain of mini ChatGPT for databases. First thing first, let's go to my GitHub. Link is available in the description. And click on Google Projects repository. Then click on Google Colab MCP1 folder. Here we will find RDBMS MCP server notebook. Copy the notebook URL and then navigate to your Google Colab account and click on File, then Open Notebook, then click on GitHub and paste the URL here. Now you have the notebook saved in your Google Colab. Now let's start T4 GPU by clicking Connect T4 button on the top right corner. Let's walk through what this notebook actually does. I have added description to every line for easy understanding. When we run the first cell, we'll get a warning that this notebook is not authorized by Google. Click on Run Anyway to continue. Here we create lightweight SQL database called DemoDB. Inside it, we create sales table. It has three fields: product, quantities, and prices. Then we insert some sample data into the table. This gives us something real to work with. Next, we have to make sure everything looks right. We load it into pandas to read the data from the table. And we can see the result is available. Laptops, mice, keyboards, monitor, all ready to go. Next cell is exactly the same. I've closed the DB connection. And that is why we can't see the result here. But if we uncomment this code, we can see the result in this cell. Now we move on to building a MCP server. We launch the server using UVCon and NoHub make it running quietly in the background. Now let's create RDBMS MCP server file. This file is our MCP server. In this file, we expose three tools: get table, run query, and get sales summary. Before we run this cell, open the content folder to verify if the file generate after running this cell. Now run the cell and we can see that RDBMS MCP server file is generated in the content folder. We can open and check the content of this file to make sure everything is correct. Here I have given another way to start MCP server, but you will see this cell keep on running, and that's why we have to use NoHub command to ensure that MCP server is running in the background quietly so that we continue running the code from other cells. Let's stop this cell and move on. Let's move on to testing the tools and MCP server. We call get tables. We run a SQL query and we compute total revenue. And we can see everything works fine. Our MCP server returning results and working without any issue. And now we are ready for the next step. In this step, we connect two worlds, AI and MCP Server that makes our system intelligent. First, we import the database tools, that is get tables, run query, and get sales summary directly from our MCP Server file. These are the same tools the AI will eventually call, but we can also use them locally here in this notebook to test everything. Then we import Google Colab's built-in AI module. This gives us access to generative AI, which we will use to understand the natural language, translate English into SQL, and turn raw database result back into the natural language result. So with just these two lines, we bring together the database and the AI side. Now we build our first natural language function called ask database. If user says table, we will show tables. If user say total revenue, we compute the revenue. If they type select query, we run it. Otherwise, we'll let general AI model to answer. Let's test this quickly here in this cell. We can see the results are generated without any errors. This shows the AI and MCP are connected and working fine. This is a big milestone. In next cell, the moment someone asks something messy like what is the price of laptop, select from the database and give me the result. The system tries to run the entire sentence as a SQL and gives error. Let's solve this in the next cell. Before we let AI run any SQL, we need to clean up the SQL it generates. Large language models sometimes wrap their answers inside the markdown code blocks. We will send that directly to SQLite and it will break. So we create a small helper function called clean SQL to fix that. Here is what it does. First, it trims extra spaces at the beginning and end. Then it removes the markdown fences like SQL. Finally, it trims the result again to make sure the SQL is clean and ready to run. This tiny function prevents a lot of errors and makes sure the SQL that AI generates is actually executable. It is a small detail but makes whole system much more reliable. Next, we introduce NL to SQL, an AI-powered translator. It takes natural language and turns it into valid SQL. If we ask how many products do we have, it generates select, count, distinct product from cell. Next, SQL results are accurate but not friendly. So we add another function, answer with data, a function that uses AI to turn raw results into natural language. Instead of showing random result like laptop, 1,200 quantity or something, we return the price of laptop is $1,200. This completes the loop from natural language to SQL, then data, and finally to natural language. Next, we import run query function from MCP server file. Even though this function is exposed as MCP tool for AI to use, it's also just a regular Python function. That means we can call it directly inside our notebook to test SQL queries before involving AI. So this import simply gives us local access to the SQL execution tool that AI will eventually call through the MCP server. It's a quick way to verify everything works before we bring natural language processing into the picture. Now let's look at the function ask database that ties everything together. The one that actually answers users' question using the database, and it follows a simple 4-step process. Step 1, we take users' natural language question and send it to the AI model. The AI converts that English question into SQL query. We also print the raw SQL, so we can see exactly what the model generated. Step 2, we clean the SQL. AI models sometimes wrap their answers in the markdown code blocks or adding extra formatting. So we run it through our clean SQL helper to make sure the query is valid and ready to execute. Step 3, we run the clean SQL against our database using run query tool. If the SQL is wrong or table doesn't exist, we catch the error and return a helpful message instead of crashing. Step 4. Once we have the database result, we pass both the question and the data to another helper function that turns raw numbers into natural language answer. So in one function, we go from English to SQL, from SQL to data, and from data to English again. In this cell, let's test everything. We can see all results together: generated SQL, cleaned SQL, and AI response in natural language. Next, if user asks exact data, like here, what is the price of mouse with capital M, then we get the correct result. But if user asks what is the price of mouse, everything small case, then system gives error. This needs to be corrected. We add error handling, so bad SQL doesn't break the system. Then we fix the common problem, which is the case sensitivity. If the database stores mouse with capital M and the user type mouse with all small case, the database returns nothing. So we add a fallback. If the first query returns 0 rows, we try using lower function. Now, mouse with capital M, mouse with all small, and mouse with all caps, everything works fine. First it takes the user's question, then ask AI to turn it into SQL query, then it cleans the SQL so it's safe to run and execute it on the database. If query returns nothing, it automatically retries with case insensitive version to make the search more flexible. Finally, it sends result back to the AI to turn raw data into natural language answer. In this cell, let's test a case sensitive issue, and we can see it is resolved now. Now let's add graph and visualization. Data becomes more powerful when visualized. Let's add create graph for single value bar chart and create comparison graph for comparing multiple values. Then we upgrade the ask database function again to include the create graph functionality. Now if the user says create graph for price of mouse, the system automatically generates SQL, retrieves the data, create a bar chart, and displays it. If users say create comparison graph for product prices, we generate a full version of chart. This turns AI agent into visual analytic assistant. And that's it. We have built a complete AI with MCP system from scratch. This is how chatbots query databases. This is how analytic tools become conversational. This is how next generation of intelligent system will work. And now we know how to build one. That's all from me. See you in the next one.